da. Ben başlayayım.
Hello everyone, my name is Osman Mert and my group mate is Muratan, and we would like to talk about absolute pressure sensors in microelectromechanical systems. Next. Here you see the list of contents in our presentation. Next. We aim to search and examine 4 different types of MEMS absolute pressure sensors in this project. In general, working principle of these sensors is to collect input from physical environment and generate voltage, which is converted to pressure value. Component materials of 4 types of sensors are shown, and working principle of the devices are explained. Also, simulations and results for each design of sensors are shown to see efficiency of the devices in this presentation. Next. Piezoresistive absolute pressure sensors. The sensors consist of silicon diaphragm and 4 piezoresistors on the diaphragm. With stone bridge circuit is included. Deep reactive ion etching method is used to produce the diaphragm, which is highly anisotropic etch process used to create deep, steep-sided holes and trenches in substrates, typically with high aspect ratios. When a pressure is applied to the diaphragm, the resistance of top and bottom piezoresistor decreases and the others are increased. Next, please. After several simulations, it is observed that the maximum stresses are observed close to the piezoresistors when 30 bar of pressure is applied, which are shown in the figure you see. To obtain excellent sensitivity and reduce the non-linearity, Mendes-shaped piezoresistors are selected. Length and thickness of diaphragm are selected as 1400 micrometer and 60 micrometer. Next, please. Design of CMOS capacitive absolute sensor. The sensor measures the capacitance between the 2 electrodes due to applied pressure on the surface of the membrane. The capacitor is made of a set of 2 aluminum electrodes, and this sensor includes 0.18 micrometer complementary metal oxide semiconductor, which is called CMOS. This sensor is produced using CMOS MEMS fabrication technique, which is a technique that MEMS devices are integrated with CMOS circuitry and a single chip to enable miniaturization and performance improvement. Next, please. As you can see in the slides, summation of displacement of sensor is shown. The maximum displacement is found as 0.2 micrometer in the center of the membrane when 300 kilopascal of pressure is applied. According to the results, there is no fracture in the membrane since the maximum stress is smaller than the fracture value. Since the obtained capacitance is too small to convert it into voltage output, 3x3 array of capacitive sensors in parallel is used. As a result, it can be converted to voltage output in order to avoid nonlinear relationship. The pressure limit is limited to 300 kilopascal. In this case, sensitivity changes less than 6%. Next.
Hi everyone, my name is Muratan. Firstly, a MEMS pressure sensor is mainly designed to measure pressure in sealed spaces of MEMS devices. As for this design, microstructures are usually encapsulated and placed in sealed cavity. This is because they can provide vacuum conditions, areas specified as spaces are of micro size, and this vacuum is very sensitive. It can be spoiled by any leakage. Therefore, the importance of this device is increasing more because it can detect the pressure in this cavity. Lastly, for this slide, you can see the image that appears on the screen. The number 44 is top electrode. The number 42 is the lateral electrodes for the bulk mode. And the number 40 is the resonant element. As for the design of the absolute pressure sensor, there is two layers you can see. The barometric pressure sensor consists of three layers. These are base layer, sensor layer, and reference layer. The base layer has a passageway between a pressure inlet and the mounting phase. The sensor layer is bonded an insulating bond to the mounting phase and includes a conductive diaphragm. The reference layer is mounted on the sensor layer to form a reference cavity. The reference layer includes a conducting surface facing the conducting diagram across the reference vacuum cavity to form a pressure sensing capacitor. As a conclusion, different designs of the MEMS absolute pressure sensor are searched and explained in detail. It's obvious that these sensors are very small, simple designed, which means they are incorporated into system or change. Power consumption is very low for MEMS absolute pressure sensors compared to other pressure products. Also, they are able to respond rapidly to small changes in pressure because the size of the sensors. Thank you for listening to us.